Oh no, that's
half and a half, quarter. Psh,
that's
tape math.
That's what the apprentice is, because we're half watts, but if they're still apprentices, they're just a quarter watt.
Is that what you really call them?
Yeah.
Oh, that's so cute. Oh, little quarter watts.
Hit the lights.
You've discovered the Halfwatt podcast. We want to educate and entertain by tapping into the most trusted source of new technology, the ones installing and innovating it. You, the tradespeople that build from the ground up. Join us as we talk with industry leaders, veteran contractors, and even some young blood.
Welcome. I'm Isabelle. This is not Half Watts. This is Trade Stacking, Half Watts' half-witted cousin.
And I am the co-host, Adam, the Maniac Garner, because I'm not good enough to be the host.
Understood.
I'm just a co.
Damn. Okay, I guess. Yep, let's do this thing. What do you do?
What do I do?
Yeah.
Oh, I actually answered this to a class that I recently taught, and I'm going to try to clean it up a little bit for the public broadcasters.
Mm-hmm.
There's a lot of people that screw things up, and I have to go unscrew them.
Understood.
So I'm the unscrewer.
Okay. Awesome. I'm
And
carpenter. Yeah, no, carpenter. I'm pretty sure I'm the one who screwed it up in the first place.
Because you use screws.
Oh, there you go. No, actually, okay. So I came into this beautiful studio for the first time, and I looked around, and I may have pointed this out, hopefully kindly, but this is so obviously an electrician's recording studio. And I don't say that because of all the like fancy electronics and everything. I say that because like all the nice wood paneling is installed with a number 2 Phillips.
Isn't that the best Phillips?
Oh my God.
You're the carpenter. You tell me. I like to use number 2s because they seem to be standard. They're not super bulky like the 3s. You don't have to have the really, really, really tiny head for the number 1s.
It completely depends on the application. I would use maybe a finish nailer or something along that line. Number 1s are really great because they make tiny little holes that you can fill in with putty, or you can proudly exclaim the fact that you are an electrician by using number 2 Phillips, which I love. It's delightful.
Now, I will agree with you on like the finish aspect of it because it cleans everything up and makes it look really nice. But I have had to carve putty out of screws to work on things. So please, I will disagree with you on that aspect. I don't want to have to dig through the head of a screw just to get the damn thing out.
Oh, boy. Okay. Well, since I have an electrician trapped here, I need you to explain to me electricity. And it doesn't need to be a full physics thing. I know we've kind of touched on this already. Mostly, I need to understand what batteries I can use with my tools. So I asked this when I was an apprentice because we all use cordless tools, and there's like, oh, you have to use this little battery with this little one, and you have to use the big one for the skill saw and all this stuff, and like they're all different hertz or amp hours, and someone explained to me that it was like, oh, this is the force that it takes with the resistance, and this is how much shocky, and none of the carpenters explained that to me. They were just like, use the big battery with the big one and the little battery with the little one. And I kept trying to get somebody to explain it with me, and they're like, you just use the big battery with the big thing.
That's fair.
When can I use what battery on what?
Okay. The first thing to keep in mind is that you should use the same manufacturer battery for whatever tool that you're doing.
Oh, that was going to be my next question.
You'd be surprised.
Well, no, because they have those little interchangers you can get on the website. That's like the like Milwaukee's or Mercury or whatever, where they have the little interchangers. You could just, and then you can make your battery work for a different platform.
Yes. Okay, so first thing, try to use the right battery with the right tool. Okay, so if you have a Ryobi drill, you should have a Ryobi battery. If you have a DeWalt drill, you should have a DeWalt battery. Now, the first reason has nothing to do with electricity. It has everything to do with how they manufactured it in the plastics. They just won't physically fit, or the terminals that release the actual electricity would be on the wrong side of the wrong location, so your tool's not going to turn on at all.
Mm-hmm.
Now, if you're a very crafty person and you like to MacGyver things and you want to take some duct tape and some wires, you can make something work, but I am not going to suggest that any listener do this because you're violating a whole lot of like safety issues that you've probably supposed to have been trained out of. And then of course you've got a battery connected to a wire with duct tape that's connected to a tool with duct tape, and that's just a big old mess. The adapters that you're talking about can work, assuming again they can fit one into the other. Mm-hmm. But here's the thing. Now you're adding additional, let's say, wiring into that circuit, which means the battery juice has to go through more circuits to deliver that same power to the tool.
Okay.
So, and this is something we call voltage drop. If I'm giving you power from 10 feet and it's 12 volts, you'll probably get 12 volts at the end of the 10 feet. If I gave you 12 volts at the end of 1,000 feet, well, I'm pulling a number out of my butt here, it might be 8 or 9 volts. So the more things that you put in the way of your power source to where you want that power to go, even if it's an adapter, can affect how much energy you're getting into it.
Okay.
So that answers the first question.
What is the volt? Is that the shock?
All right. So there are three things that everybody needs to keep in mind when it comes to electricity. I'm not going to go into the physics. Okay. And people like to compare it with water. They often say, oh, electricity and water, they never mix. That's actually inaccurate. Water and electricity mix far too well, which is why we don't want them to mix at all. I'm not going to use the water example because some people still don't quite grasp that. So I'm going to use an arm as an example. You have volts, you have amps, and you have power. And there's some formulas. Volts into watts will give you power. You increase your volts, you decrease, things like that. We're not going to do math here today.
Thank you.
Yeah. Think of it like this. And I'm not advocating for violence here for a second. It's just a metaphor.
Sure.
So if you punch me in the face,
yep,
that has some factors involved. First is the speed in which you punch me in the face. Mm-hmm. Okay. The second is how much muscle mass you have behind that particular punch. And the third is the force that I feel on that punch. So if you punch me in the face, it's going to hurt.
Yes.
Right? If I punch you in the face, it's going to hurt. Mm-hmm. Now, we've just changed the parameters because I have a different size arm, I have a different size muscle mass than you do, and I hit you with a completely different force. That's kind of how energy and voltage works, because if I say a 6-year-old's going to hit you at 5 miles an hour, slap you across the face, it's going to have a particular pain threshold. But if I hit you across the face, well, my arm's twice as big. I have a lot more muscle than a 6-year-old. It's going to hurt a lot more.
Sure. I would hope.
Yep. So the muscle that puts into it, the speed at which you're hit, and the force in which you feel that are your volts, your power, your amps, and your output wattage.
Okay.
So amps are basically like the muscle mass.
Okay.
So volts are kind of like the speed, and then power in your watts is essentially the impact force, if that makes sense.
Go over that again. So, wait. Amps are the speed.
No, amps are like the muscle mass.
Amps are muscle mass.
Mm-hmm. Volts are kind of like the speed.
Volts are speed. Okay. And the other one?
And then your wattage or your power is essentially the striking force.
Got it. Okay. That kind of makes sense.
Yeah. So volts, they're the little thing. Mm-hmm. Amps are the scary thing. So have you ever licked a 9-volt battery to see if it still has juice?
Nope.
Okay. Well, everybody can do this.
Okay.
It's like, I don't know if it has juice. Well, you take the 9-volt battery and you just stick it on the tip of your tongue.
It's not something you just tell apprentices to do to get a good laugh or something.
Well, I told, he wasn't an apprentice, but he worked with me. He asked me, hey, I don't know if this battery's dead. I'm like, lick it. He's like, haha, I'm not going to do that. I'm not joking with you. Lick the terminals and tell me whether or not you get shocked. He's like, I don't want to get shocked. I'm like, it's 9 volts. It's not going to hurt you. It's going to be like a little tiny tingle. So I will do it in front of people so they know that I'm not just pulling their leg and trying to be a practical joke. But you'll get just a little pinprick, if that. It's like drinking coffee and just, oh, hey, I'm awake now. No big deal. So that's volts. It's not really going to hurt you. Amps are what kill people. Because a lot of people don't know you can actually die from milliamps. There's a particular threshold of when things start hurting and when things get painful versus what just shocks you. So,
Okay.
Perfect example, you could go on Amazon today and buy a 250,000 volt stun gun.
Mm-hmm.
I will say it probably doesn't have 250,000 volts. That's a lot of voltage, and I don't believe for a second that comes out of that gun.
Uh-huh.
But you can take a lot of voltage. I get shocked by 110, 120 on occasion, and, it's like, ooh, hey, that tingles, and then you go about your day.
Is that what you do when you forget your coffee? Find some exposed wiring?
I don't drink coffee. I just stick my hand in the light socket and go, okay, I'm awake, and off we go. But the amps, that's the dangerous part. Again, why the muscle mass is the concerning part, because a single lamp can stop a human heart and then it's over.
And why is that?
So going back to not the physics aspect of it for a second, but electrical theory, the human body is actually generating a certain amount of current voltage. They actually made a movie about this. It's The Matrix. When it came to, that's all theories.
Is that why you became an electrician?
No, not at all. It was an amusing movie, but like the science aspect was, it's all theoretical, But your brain is emitting pulses, your heart is emitting pulses, your body is constantly generating certain pulses that essentially keep your entire system alive.
Yeah.
So like a computer or any electrical component, if we throw just a little tiny monkey wrench in that, it will shut down your system. So essentially, I don't know the actual numbers off the top of my head, but let's say your heart is operating off a particular pulse pattern, which they all do, and I interject a stronger pulse than what your heart is capable of, I can stop it, and that pulse goes through the rest of your system and essentially shuts down that particular motor function. So your heart stops, and then you're dead.
So this leads me to another question I have. You go through the job site and there's like exposed wiring sometimes, or just like stuff hanging down, and you'll ask an electrician and they'll be like, that's fine, like that one's fine, just leave it, or something like that. Like,
well,
what?
When you mentioned that the studio was an electrician's, I was saying, because of all the wires that are hanging around everywhere. No. There are a lot of wires in the studio. Yeah. They're in buildings, and this is electrical theory. Electricity follows the path of least resistance in any situation. That's why circuit boards and buildings are designed the way they are. Way back in the day when we didn't really have codes, people could and were electrocuted in office buildings by picking up a phone handset and answering a phone call, because according to the physics at that specific moment in time, that was the path of least resistance for whatever energy just hit them. So now we have what we call grounding buses and grounding rods. So every piece of electricity in a building eventually goes down into the dirt in a much quicker and safer path than through you or somewhere else.
Oh, that makes a lot of sense. Okay. Do you have to go to work on places that have like knob and tube wiring or anything like that?
Not much anymore.
Okay.
So it might take a while, but we as a species do get smarter.
Well, I'm just wondering, because you get into old places with, carpentry and stuff, and you look around and you're like, well, at the end of the day, like, wood is wood. There's, you can shove a board in there, and be like, fine. But I can't imagine going in someplace and be like, wow, this is some beautiful, like, knob and tube, and you have all that, like, the cloth is coming off the rubber and things are kind of hanging down, and Joe Schmo down the block did a bunch of renovations in the 60s, but then his brother came in and tied a bunch of other things in, and now it's 2010 and nobody actually knows what's happened.
You can't say with a straight face that wood doesn't have those same problems. Well, here's a perfect example, and you can correct me because you are the carpenter in this room. I should be able to just go get a 2x4 and build a house with them, right?
Yeah.
Yeah.
I mean, okay, sure.
See, like, what's the difference between a regular 2x4 and a pressure-treated one?
They just jack it full of chemicals so it'll withstand water, essentially any type of water damage. That is, I've heard debate on the pressure treated for whether or not it's safe, and I think they've changed it over the years, because a lot of times you'd see, like, people building garden beds or children's playground equipment and stuff with the pressure treated stuff. And they'll be like, oh, no, it's super toxic. Like, if you get a sliver from it, it'll get all infected and all this stuff. And other people will be like, no, that's only old. And, like, I don't know. Personally, I like to stick with, as close to natural materials as I can. So I don't do a lot with pressure treated, but, I don't do a lot of, like, decking and stuff like that. I'd rather build furniture and cabinets and stuff. But yeah.
But there are differences.
There are absolutely differences. Yeah.
Like what kind of a wood lady would you say you are? Are you more of an oak or a cedar?
Cherry.
Cherry?
Cherry.
Why?
Yes. It's a hardwood with just this beautiful color to it.
Why can't I just stain like oak to get that same coloring?
It just doesn't look as good. It also smells different. Do you ever huff wood? You can.
She's on to me.
Man, look, it's something I picked up from a foreman where, like, we would work with real wood and you just pick it up and it was like. But you can smell the difference, especially if you've been, like, drilling a lot of it, and I've drilled into, like, a lot of oak, but you can smell that burning, or firewood or whatever it is, and you can smell the differences. Okay. Okay. Okay, so we already covered if I'm going to explode if I touched wires.
You're not going to explode if you touch wires. Okay, here.
What if I run over your wires with a cart? Is the electrician going to explode me? Like
what? Just a push cart, a rubber?
Like a Rubbermaid cart? Like, is that going to hurt anything?
Not at all. No, people. You shouldn't fear any wire with a jacket on it.
Okay.
Generally speaking.
Okay.
If there is exposed wire, like you've got shiny copper or aluminum or any other equally conductive material, then you should potentially avoid it. And of course, take any of the danger signs very seriously.
I see. Are you only saying that I should avoid copper wire so I don't scrap it?
Well, don't go into buildings and rip wire out.
Just curious.
Well, there was a building that I actually worked on that I had to kind of put back together after it was ransacked.
Oh, seriously?
And
Were
one
they
of the
going
things,
after the copper wire?
Not just the copper wire, but all the copper in the plumbing as well.
Oh, man.
Yeah, so they were getting into
so
faucets. Oh, it was bad. But it was also insanely dangerous because one of the things that we found was one of the axes that they were using to cut through the
They used
lines.
an axe?
Yep. Wow. Now, the fact that a body wasn't sitting there charred was lucky because they were cutting through some pretty serious feeder circuits. So we're talking into the thousands of volts, into the hundreds of amps. They're lucky the building didn't burn down.
Mm-hmm.
Lucky they didn't die during that particular process.
So that's when you really got to use like a wood-handled axe for that stuff. No, like hollow metal.
I can't comment
pipe
on
and
what
handle
materials
nonsense.
you should or should
Okay.
not use in the event of breaking
Wood-handled
the-
axe. Got it.
Yeah, but no, there are certain times you should be aware of the dangers of electricity, but generally, you can go plug something into a wall, you're fine. If you get behind the wall, you should be aware of what you're doing because, a lot of people like doing work in their own houses, right?
Mm-hmm.
They're like, oh, I can do this. I saw an electrician do it all the time.
Mm-hmm.
I had somebody call me up because they did their own wiring and they put, I think, 10 GFCI plugs on a single outdoor run that was connected to their second floor bathroom circuit for some reason.
Did they explain why?
Well, they didn't know where the power came from.
Okay.
I was like, okay, well, where are all these things going? They're like, oh, they're going to go on the deck. Like, why do you have 10 plugs on your backyard deck? That's just a lot. It's like, well, I wanted to be able to plug in no matter where I was. What the hell are you plugging in? It's like, oh, maybe my laptop, maybe my electric grill, maybe a couple of lights. Like, what exactly are you hosting like a party off of this one single bathroom circuit? He's like, yeah, and I just want to be, really concerned. Like, yeah, you should be. Go call an electrician to actually wire this because this is a terrible idea for you. You're going to overload the circuit. You're going to pop every GFCI. Just a whole bunch of stuff was going to go wrong. And worst case scenario, who burns his house down?
Yeah. How do you burn a house down with that stuff? You just like overload it too much? Oh, better question. What's the dumbest thing you've seen someone do on a job site with electricity? Do you ever like walk up to a spider box and you're like, this thing is 10 seconds from exploding?
Oh, there's the very, very common one where somebody needs to use a cord and they can't plug the cord into the socket because the socket doesn't have a grounding pin. It's like, I'll just cut the grounding pin off.
Okay. Yep.
That's probably the dumbest thing. Because again, we talk about path of least resistance.
Yeah.
The grounding rod is supposed to be that path. So let's say you have to go cut, a massive wood beam, right? And you're probably going to use like a sawzall or something, right?
Beam saw.
Beam saw?
Yeah.
All right, that's got to be a powered unit, I assume.
Yeah, giant saw. Oh, kind of like a skill saw, but big.
All right, so you're going to take a giant skill saw and you need 110 for that, at least. So you got to go find a plug. You're like, okay, I'm going to go, hey, here's a spider box, but for whatever reason, you don't have an extra plug in the spider box that's available that has a grounding lug. I don't know why they would make a spider box without grounding lugs anymore, but this is all theory. And you have an extension cord and you go, oh, damn it. I need power, but I can't plug this in. Well, I know how to do. I'll just cut the grounding rod. All right. So you cut the grounding pin, you plug in and you go to your awesome giant saw and you start going to town on that beam. Now, for some reason, there's an electrical failure, and that energy has to go somewhere. But you just took out the path of least resistance because you cut the grounding pin.
Okay.
So what becomes the path of least resistance?
I am the path of least resistance.
You might be.
Does it depend on what kind of boots I'm wearing?
That is a factor, yes. Because when we talk... Here's a great way to think about this from like a physics perspective. Have you ever seen a lightning bolt?
Yes.
Now, does that travel in a straight line?
No.
No, it kind of zigzags, jumps around, does weird things. At that particular moment of time when it comes to the physics standpoint, that jump is the electricity going to what it sees as the path of least resistance and then continues down to the ground.
That's fascinating.
So if you ever see a lightning bolt, you're like, oh, I know why it does that. Now, it's raining, there's lightning, there's air pockets, so this goes into really complicated physics. And like, well, why did it take a left instead of a right? Why did the lightning go 10 feet that way instead of 5 feet that way?
Yeah.
That's what gets down to the physics. We don't quite understand, like, on that level why it chooses that. So, but as you're using that giant saw, the electricity is going to make a choice as it deems necessary as the path of least resistance. So the boots you're wearing can make an impact. This is also why electricians are not allowed on metal ladders when they're working.
Oh, I never thought about that.
Because we get fiberglass or, even wood construction, if they still let you, because we would then create a path of least resistance.
I've never seen a wood ladder on site.
Yeah, they don't really make them anymore.
No.
So you could be it. The spider box could also be it. That grounding plug or the grounding pin that you cut off, you didn't cut it flesh. So the grounding pin is still touching the metal spider box. So you potentially just energized the spider box with 110.
Damn, I didn't think of that.
So there's a lot of factors at play. And people are like, oh, well, it's fine. It's not going to do anything.
Yeah.
What if the piece of wood that you now have a giant circular piece of metal going into decides that wood is now the path of least resistance, and I hit it with, I don't know, how many amps do you think your saw runs?
That is not a question I know any answer to.
All right, let's just say 10 amps, for example.
Okay.
So that muscle mass, it's going to hit that wood really hard, and that much energy, one of the byproducts of generating energy is heat. So you have now just set that wood on fire. And then, of course, as you're sawing it, all that sawdust that you're kicking out is now a flamethrower.
Nice and flammable?
Yep.
Okay.
So worst case scenario, you invented a flamethrower.
Yeah.
Or you shocked yourself and died or something. Or anyone who's using a tool that's connected to that spider box that you just energized is now getting shocked, if not electrocuted.
Man. Do you see that kind of thing a lot?
No.
Okay.
Because, again, the spider box is usually connected to something that is the path of least resistance. So there's a lot of double checks. But it's stupid for people just to go and bypass safety features.
Yeah.
Like on your saw, is it one of the really cool ones that you could put a hot dog in and then the blade will stop?
No.
It's not flesh sensing?
No.
Why not?
I've only seen that on like saw stops, like table saws.
Yeah. But imagine you had one of those and your company got you one, so you're feeling a little bit better, right? You're like, okay, if it feels my finger, I'm just going to have a small cut because the flesh sensor will go off and then it will shunt the machine and it will be down. Now imagine that your coworker came over and is like, hey, can I borrow that? Sure, no problem. They go and borrow it. They disable that safety feature and then they hand it back to you. But they didn't tell you they disabled it. Well, now the next time you think, oh, it's going to stop. Well, now you're missing a digit.
Yeah. Yeah. Okay.
So that's the dumb thing that I see people do more often than not is they bypass safety features like that.
Got it. Huh. My old boss told me he bought a skill saw from a guy who had at one point, you cut the cord on a skill saw occasionally. And so he had...
Okay, they're just going to cut the cord. Why not?
You're cutting a bunch of stuff and there's a cord and, accurate angle and,
That would be someone who's not very skilled with a skill saw.
Maybe somebody put the spider box in a weird place and you're trying to stretch the cord and you, run through it. So, you could just, put a new plug on there. But my boss was telling me the guy he bought the saw from had, done it wrong and, switched the wires up and then it shocked him. So instead of doing the grounding one, he did the other one. It shocked him, but he couldn't let go, and so he ended up cutting into his leg.
Okay, so you remember how I said we have electrical pulses going through the human body at all the times?
Yeah.
So this is a massive danger in electricity because the electricity will overload your system. So your brain can't send the pulses to your muscles because that electricity is overriding them. So in a lot of locations, and people can watch videos of this because it's awesome, they have what's usually referred to as the dead man's stick. So this could be a baseball bat, a hockey stick, a giant piece of wood. Because if you go and you work on a massive panel and you have to go with somebody else, and then suddenly you stop moving, they are to take that and break your arm with it. They have to separate you as quickly and as safely as possible. Because if you're sitting there and you've locked up, your entire body is energized and you're basically being electrocuted to death.
Yeah, you don't want to grab that person.
Yeah, and that was the mistake that people made in the past, where they're like, "Hey, what's going on?" And they would touch that person, and then they become part of the circuit, and now you have two people that are being electrocuted.
So do you guys all just carry a stick with you to poke people with?
Generally, well, it depends on the circumstance, because you might go to locations where you can see, why is that giant piece of wood there? It's to break somebody's arm. You're like, whoa, why is that necessary? To save their life. Sure. Really, really big ones, there's usually 3 people involved. The person has this massive get-up where it's like an old spacesuit. Almost. I
have been so curious about that stuff. Okay, continue.
So he'll dress up in this massive, looking like a spacesuit, sort of like the Back of the Future movie, that weird getup that he has. So the person who's working on the system will have that, and they'll have massive rubber gloves, and they'll be as insulated as possible. And then on one side of them, they'll have a spotter who's all they're doing is they're looking for any potential possibility that you have stopped moving or you're no longer communicating with them, because they'll try to keep communication constant. And if you're not responding more than, a second, you're done. Yeah. They're getting you out of there. And then there's a third person who has a very large pole, and that pole is actually wrapped around the person in the spacesuit, because they, once they get the command from the spotter, are just supposed to yank that person out as quickly and as hard as possible.
Really?
So
when does that actually happen? In like, how many places are like bringing in spacesuit boys to like do the electrical work?
Generally not often, because most of the time we turn equipment off before we start working on it.
Right. I'm trying to imagine what circumstance, like, there's just no potential way to get temporary power or to, turn it off for a set period of time.
It could be like an emergency service, or they might be working on, let's say, a section of the power grid, and they can't isolate it for some reason, or the isolation is broken, and that's what they're there to fix, and they can't move things over to a different substation. There's a lot of possibilities, but they're also quite specific.
Do you get like hazard pay for that?
I hope they do. It's like, all right, we're going to go work on something today, and if we don't follow these procedures, you're not going home. It's like, I think they probably should.
Yeah. I'd imagine you got to make bank for that. How do they pick the guy who just like stands there with the pole? It's like a short straw?
No, I mean, if it were me, and this would be my decision, it would be, all right, who's stronger than the other?
Oh yeah, that's fair enough.
Yeah, because we're
send the smallest guy in with the end in the suit so they can just yard him back.
Yeah, just yank him back. Look at those bad Looney Tunes where the guy's on stage and the pole comes out and just yanks. Yeah, that's basically what that is.
Well, it makes me think of like, I know my welding instructor was a saturation diver, where like, you stick you in a teeny tiny little capsule and they bring it down to pressure, and you stay at pressure for however many days so you can go weld at the bottom of the ocean and stuff. And like, tiny guy, and I'm like, they must just pick these dudes by size to like keep them, because you're keeping them in these little capsules. So I'm just like, are they all this tiny? Just like pocket-sized welders?
No. fun part about that, because fun fact, I'm a certified diver.
Oh, seriously?
Yeah.
Nice.
So when you're dealing with that level of compression,
Yeah.
okay, two things. Number one, if you go there when you're younger, that amount of compression can actually stunt your growth. So if you're doing like deep sea diving, like when I was young, I wasn't allowed to go below 40 feet because they were worried.
What do they consider young? Like child or like 25?
Basically anybody who hasn't hit puberty yet, because that's
Okay.
when you hit your growth spurt and then you get tall or not, depending on circumstances.
Yeah.
But if you are subjected to that amount of compression, then that could create long-term effects that could potentially stunt your growth.
Was it commercial diving you were doing? You were working?
No, I was just doing it for fun.
Okay.
Yeah. But now that I have it, I could go and do stuff.
Yeah.
But the other thing was, before we learned about compression, people would go deep sea diving, they'd come up, and then like the next day they'd be dead.
Right.
And they'd have no idea what happened. So, not to be weird about this, but in that particular case, size doesn't matter. But maybe the equipment that they have, because it's like, oh, we only have this sub, and if you're over 6 feet, it's going to be cramped. You're not really going to be able to fit in it with all your equipment.
Yeah.
So send the little guy.
Yeah. Oh.
Yeah. Just like you got to crawl under a house. It's like, okay. There was one that I actually had to recently go into that we decided collectively that I could not physically fit in it.
Right. Man, I am not a small person, but I am a small construction worker, and they have used that to force me into the worst ceilings. They're like, well, we can't fit, so you got to go up there. I'm like,
It's just, yeah, that's some bull crap.
oh, I know.
Never let them do something that they're not at least willing to do.
Oftentimes I think they would be willing to do it, but just they're like, I just can't fit. So
I mean,
sure.
there is that.
Yep.
There have been a couple of times when I've been like, I'm willing to do it, but I physically can't fit in there. Mm-hmm. And then potentially get out. And you're like, well, why do you think I can?
Yeah.
It's like, well, because you're smaller than me, and I can hold on to your ankles and yeet you out of there when I'm done with you. They're like, well, I guess so. It's like, I'm not going to be a dick about it. But sometimes you do have to do questionable things. Mm-hmm. There's one that I'm looking forward to. Mm-hmm. And I keep reminding people I am not going to jump off the building, but I am going to rappel on the outside of it.
Nice.
Because I have to do
How high up?
6 stories.
Okay, it's pretty far.
Yeah.
What kind of electrical stuff is on the exterior up 6 stories?
It's called a heat trace wire.
Uh-huh.
So essentially, if flame hits the wire, it melts the jacket, and the 2 wires touch each other, and then they create an alarm state. So it's an interesting design because there are trees on the outside of this building. So what happens if the tree catches fire? Well, we got to deal with it. So I have to go trace that wire and find out what's wrong with it. Or get to go work at a nuclear plant, or get to go work at underneath somebody's house, or in a crawl space.
Yeah.
Yeah. How about a subspace? You ever been in one of those?
No, I don't think so.
Yeah. So you build a house or a business that was built on top of another one. And when you're running the wire, you realize there's a whole other floor. So not only do I have to crawl under the floor, I have to crawl under the floor that's under that floor.
Oh, man. Okay, but I love that stuff. Like, you're going in these weird places that, like, nobody ever goes. Mm-hmm. That's cool.
It is.
It sounds cramped, but...
Yeah. Yoga helps.
Sure.
or as a lot of companies do, and I always suggest the old stretch and pull in the morning. Get your morning stretches in, especially if you're going to do something crazy, like you have to climb up into a ceiling and then dodge all the sharp wiring and hot equipment and other things to reach what you're trying to reach.
Yeah.
So it could be a little weird,
Yeah.
especially when you have another trade that's asking you to do that for them.
Oh, yeah. Speaking of which, what's the most annoying thing other trades do on the site? Since we're in trade stacking.
Okay.
Like, give me the dirt.
We
Are like carpenters doing shit, or is it like plumbers? Come on.
All right, we're gonna talk stereotypes here.
Yes. Oh,
so
absolutely.
Nobody can hold anybody, especially me, or the actual host of the show, because I'm just the co-host. We talked about this and we agreed. There are some. Now this could also be a local thing too, right? Elevator technicians.
Oh my god. Oh my god. The elevator constructors are separate from technicians? I don't know. Okay, continue.
All right. Well, just like any trade, there are different aspects of trade. You know, so for example, you have the elevator installers, and then you have the elevator service guys. Now, I will say that I've worked with a lot of elevator guys, and I have yet to have one admit to me that they. Well, hold on. I was about to say that in reverse. They've admitted that they didn't know what was going on. But they're very particular because they should be. It's their space and their equipment, and they get to run the show. Some of them can be a little diva-y about it.
Oh my god. I can't even with the constructors.
But I will say that's not elevator specific. That definitely seems to be like a personality trait that kind of goes into any field where somebody becomes more specialized. Then they get this attitude of, well, I know what I'm talking about and you clearly don't because I had to learn this particular specialty and this is how it is.
Yeah, that's why I always run under the assumption that I just know nothing. It works out great. You learn a lot.
I wish more people had that particular position.
Yeah.
Because if you think you know everything, you won't learn anything.
Yeah.
You won't get better.
I specialize in doors and hardware. I am wrong all the time when it comes to doors and hardware. Pretty much everybody is. You just
So speaking
learn
of
as
you,
you go. Yeah.
doors and hardware people and locksmiths,
Yeah. Oh my god.
generally in my experience, okay.
Oh, good.
Yeah.
Good.
Generally
Glad
okay.
to know, because we work with the electricians a lot.
Yeah. Now those dirty, rotten, stinking electricians. Oh boy. Where can I begin?
Leaving those piles of string everywhere for no particular reason.
Not tying their pull strings off somewhere, taking the pull string that somebody else left in and not replacing it with their pull, thinking that they own the show because they bring heat and power and light to the world.
I know.
You can't trust them. Not one bit.
Yeah.
You know. Sheetrockers.
Okay. Do they bury your stuff?
All the time. So I have made a goal that anytime I'm like, okay, sheetrockers are coming after the fact, I will not just put my wire out like a foot away from where the wall is, but I'm like, well, they could just shove the wire back in.
Yeah.
All right, metal rod. Just stick a metal rod out.
So there's just like a metal rod sticking out of the wall?
Well, then they know, because most of the time they either don't know or they forget or whatever the case is, right? They have a job to do like the rest of us, so they go and slam the walls in, right?
Or they trip on one piece of conduit and they're like, I'm done with this.
Yeah. So they bury your stuff. And then you go, where's my stuff? All right, well, how are you going to find it? You get out the knife and you start poking holes in the wall.
Oh, so is that how you find it? I was going to ask.
Now, generally, if you put it in, you have a fairly good idea of roughly where it is. But you tell your customer, your sheetrocker's buried my stuff, and now I have to find it. And they go, well, how do you do that? Now, there's an awesome new tool that an electrician showed me.
Is it one of the little x-rays?
No. It's a cable sniffer that basically gives you a percentage value of, so I hook it up on one end of the cable and then I can go trace the wall with it. And as long as I'm close to like 95 to 100%, I have the wire so I can trace it in a wall that way. But if you don't have access to that several $100 piece of equipment,
Yeah.
get a rock saw and go start poking holes.
Start poking holes.
But you tell your customer, I didn't have a choice
Yeah.
because your other contractor buried my stuff.
You know, I can't be surprised because we do that to find studs sometimes. So we just take a screw and you're like, till you hit something solid, and you just hope it's not plumbing.
Or, okay, because I can blame you sometimes for this as a carpenter, right?
Yeah.
All right, so would you say a carpenter is responsible or not responsible for putting the studs in the walls?
I mean, I would hope the carpenter was responsible for putting a stud in the wall.
Okay, so
Hopefully.
I mean, if it was like a wood carpenter,
Not just
right?
like, loose sheetrock. Yes. Or metal. I think, God, at least in where I'm working, pretty much everything is metal. But yeah, wood, metal. Once wood, always wood. That's the rule.
There you go.
Yeah.
I like that. That's a good rule. So now this is one of the reasons that I agreed to do the trade stacking, because I think I have become a better worker because I have learned the things that other trades do.
Same.
So this is this is your tech tip of the day here, people. Always be willing, even if you're not doing the work, be willing to learn how the other person does their job, because if you understand that, you can understand how I can do my job to make their job easier, or vice versa.
Yeah.
And I'm not just talking like, hey, electrician, I have to run a bunch of wire with you. Can I buy you a 6-pack of beer so you can just run my wire? Which is something that can be done too. But so I've learned a lot about doors and studs and woods and whatnot. So typically, if you were going to frame a door, how many studs would you use?
I mean, I'm going to be honest here. I'm a finished carpenter. I don't frame doors. I put in door frames. I mean, but you have the, king studs and all the other studs and studs and studs on studs, headers, all that stuff.
So the consistency,
There's
right?
There's 1, 2, 3, 4, 5, 6-ish, I want to say. Oh, man.
Well, typically with the door...
Oh, someone's going to judge me here. Jeez.
We're talking
Didn't know
about
I was taking a test. Okay.
Typical from our experience, right?
So from my experience, it's metal studs and it's in place. Okay, but continue.
But there are some theories.
Yeah.
Like if you're going to frame a door, generally you might double stud it because you have to frame the door to the one stud and then you have the support stud that goes with it. So if I'm going to work around a door, let's say we're going to do a lock set together.
Yeah.
And you're going to put the door in and we have to go through a hinge. We have to bring the wire down on the wall. We have to go into a transfer hinge, which is a hinge, for those that don't know, that specifically has wire built into it so it can move and flex and not get damaged. Then the door has to get cored. So somebody has to take a drill bit and go from one end of the door to the other end of the door. And I will not do that because I'm not that good and it's not my door. So I trust the locksmiths or the door people who have years of experience to do that for me. And then you're going to get to the actual handset where the wires will end, and then you wire up and do all that. So knowing all of that and how the design of that door works and how it's built, you can tell yourself, okay, I have to go through 2 studs, and then I have to go into where that hinge is. So you understand how that works, so you understand what you're going to have to do. So if you're working construction, this is a great time to see how a building is built so you can see the skeleton of it.
Yeah.
Because there are some quote unquote standards. Like what would be the typical distance between studs in a wall?
18 to 24 on center.
That's the problem. 18 to 24.
Right.
So
no,
like,
I know.
Did they go 18? Did they go 24?
Oh, what did the engineer say?
Yeah. So when you have when you got a wood stud, again, there's still some variance, but you could say typically a wood stud might be about the size of a 2x4. But with the metal studs, okay, did the hard frame of the metal stud go on the left or the right? because with the wood stud, you have them on both sides.
Yeah.
But on the metal stud, that makes a big difference because you're going to have to put something against it, or you're going to have to run wire in the stud so you know it's not going to be affected by anything else.
Yeah.
So knowing how the construction process works makes you able to run your cable better. If I know I'm going to deal with a lock set, I'll go talk to the locksmith and ask him, what your equipment is, how I can bring the cable to you better, whether or not they're going to be responsible for coring the door, what kind of a hole they're going to have to drill for me, all that stuff.
Yeah.
So it's good to know, even if you're never going to personally apply that in your trade.
Yeah.
Right. So you would be framing something. Well, not you, because you're a finished carpenter.
I'd be setting cabinets.
Actually, this is something also that I've worked with finished carpenters and other finished people before. There was a building that I had to run an external card reader to because it was like a clubhouse, if I remember correctly. So two large finished pillars on the outside and then the door. Yeah. So they said, okay, get the card reader down there. But it was already finished. I was like, okay, can I have a conversation with your finished carpenter? They're like, all right. So we got to chatting. I'm like, all right, is it hollow? And they said, yes, about 6 inches in. Mm-hmm. It's like, that's going to be a hell of a drill and a hell of a pull. Mm-hmm. I'm like, okay, what's the material I have on the outside? And it was kind of like a slatted wood, if that's a good explanation for it. Not something we really wanted to affect at all. Yeah. But it was right against the pillar itself. So I'm like, okay, I don't have any space between that. So we got to chatting and I was like, well, how is it connected to each other? Like, it's not connected to each other. It's connected straight here with a couple of screws on each end. I was like, and what's the material that's surrounding the pillar? It's a foam insulated base, and then it goes to the actual concrete. It's like, I have a perfect solution. Take off one edge that goes to a corner, and then I'm going to carve a diagonal down the corner, and I'm going to run my cable right through that and out. Mm-hmm. And it worked perfectly. It didn't impact the finish work. I didn't have to destroy too many things to get to it. And I gave myself enough space where the cable could go and I could still secure it, and everything worked out great. Right. So, but I had to work with the finished carpenter to get that done and understand how his construction process worked.
Yeah. No, we had a issue where, when we finally get to actually take control of the projects a little bit more and get the information ahead of time and dig into it, because oftentimes you just, we kind of get thrown on a project and you just get what you get. But when you actually are able to have some control, like I was on one where the whips they sent to go through the doors were too short. They wouldn't fit. So we were going through all this hardware and finding all this stuff, and it was just like, ooh, I don't know if this seems to work. So, we found the electricians, we talked to them, and they're like, because we provide, and we're like, okay, we can either throw these up with the hardware we were given and just walk away. But, you talk to the electricians, they're like, oh, yeah, here, let me, make up a bunch of these cores real quick, tell us how many you need. And then we're able to get everything wired through and fix it so that, when it is their time to come in and get things done, it's set up. It makes it so much better, in my experience, when, everybody's not fighting each other for space and fighting each other for material and trying to get this done. If you can just, talk and work through it, the whole process goes so much more smoothly.
Well, I think all the trades should be more, let's be fair. A lot of them are more collaborative than we often joke about.
Yes, absolutely.
And because it is basically us against the particular project that we're dealing with. And I don't understand the point of being a dick to the person you're supposed to be working with to help you.
Right.
Yeah. I did have an electrician accidentally throw away 40 jumper wire connectors that I needed for some hardware. I was a little irritated by that. I'm like, well, I can't do anything about that, and we can't go back to the manufacturer about this, so cut and bean. That's what I'm going to do.
Right.
But, you know, he admitted, oh, yeah, I didn't realize that was an issue. My bad. It's like, no worries. We're not looking to blame anybody except stinking stud people who shove their studs up against my stuff and cut through my wires and don't admit it.
Ooh, I never thought about that one. Yeah.
You HVAC guys, too.
HVAC.
They just slam their equipment in. It doesn't matter what gets crushed in the process. But again, I'm making stereotypes and generalizations. Some people are better at it and some people are worse at it.
Well, hopefully we can all get a little better at it.
That's the point of this, right?
I know. Yeah, and I think with that we are about at time. So, until next time.
Yeah, I have been Adam, and you?
Oh, Isabel.
Yeah.
Good working with you.
Yeah, shoot us your trade information if you want to be part of the podcast or emails at halfwattpod@gmail.com. Do all the social medias and all that mumbo jumbo, and we will see you on the next one.
Cool. Thank you.
Thanks for listening to the Half Watt Podcast. We always want to hear from you, and we encourage you to email us at halfwattpod@gmail.com with questions or even your own stories. Funny, crazy, or praiseworthy, we want to hear it all. You can follow us on Instagram at halfwattpod to stay up to date on our feed. And be sure to subscribe wherever you listen to podcasts. And share us with a friend, the best way to help us grow. The Half Watt Podcast is a production of Now Hear This Studios.
Welcome back. After thinking about things for a minute, I believe I said studs were generally 18 to 24 in center, and I know some of y'all were yelling at your phone when you heard that. I meant 16. I am a carpenter. Thank you.